Welcome to The Explainer. Today, we're diving into a technology that powers pretty much everything, from your e-commerce recommendations all the way to deep space analytics, Apache Spark. You've probably heard the name, but what is it really? Okay, let's get into it.
So the headline feature you'll always hear about Spark is its speed. And we're not talking a little bit faster. In some cases, it can be up to 100 times faster than the technology that came before it.
Right. To answer that, we actually need to understand the problem Spark was created to solve in the first place, a problem that was born from the absolute flood of data in the early 21st century.
See, as the internet just exploded, organizations were suddenly facing this tsunami of data, way too much for a single computer to handle. The answer was something called distributed processing, basically using a whole cluster of computers to tackle one giant task. The first hero in this story was a framework called Hadoop MapReduce. It was a game changer, but it had one fatal flaw.
And this right here, this reveals Hadoop's biggest weakness. Imagine after every single tiny step in a big job, it had to write the results down to a slow, physical hard disk. Then, the very next step had to read all that data from the disk all over again. This constant back and forth, this I/O, it created a massive traffic jam for data.
So Spark was developed back in 2009 at UC Berkeley's AMP lab, and it was designed with one main goal: to absolutely smash that bottleneck. And its core innovation? Well, it was brilliantly simple.
Instead of constantly writing to that slow disk, Spark keeps everything in the computer's super fast memory, its RAM. And this, right here, is how that 100x speedup is even possible. By just eliminating the slowest part of the whole process, the entire workflow gets this incredible acceleration. Okay, so it's super fast. But how does it manage all the work across a whole bunch of different machines? To get our heads around this, let's use a fantastic analogy: a high-end restaurant kitchen.
First up, you've got the cluster manager. Now you can think of this as the restaurant manager. They're not cooking the food, but they are making sure the kitchen is properly staffed and has all the resources it needs. You know, the chefs, the stations, all based on how busy it is. Next, when you submit your code, that's the order, it goes to the driver program. This is our master chef. The master chef takes a look at the entire recipe, figures out all the different steps, and then creates the master plan for the most efficient way to prepare the entire meal.
And finally, we have the executors. These are your assistant chefs. They don't create the plan, they just do the work. The chopping, the sautéing, the plating. They just execute the specific tasks given to them by the master chef. And because you have a whole team of assistant chefs, all this work happens in parallel. So the key takeaway is this: the driver orchestrates and the executors execute.
But here's the thing. Spark isn't just about raw speed. It's also incredibly smart about how it works. And it does this using a core principle called lazy evaluation. This is what really separates it from just being a brute force tool.
Okay, so this is really cool. First, you give Spark a whole series of instructions on how to change the data. Things like filter this, sort that, group these together. Spark builds out a logical plan. But, and this is the key, it doesn't actually do anything yet. Then you finally ask for a result, like, hey, count the records or save this file. Now, and only now, Spark looks at the entire plan, optimizes it, finds shortcuts, and then executes it in the most efficient way possible. It waits until it knows the entire recipe before it even turns on the stove. It's that lazy approach that makes it so efficient.
So this combination of speed and, well, intelligence makes Spark a true jack-of-all-trades for data. It's a single unified engine that can handle pretty much anything. You can query structured data with Spark SQL, process real-time live data streams with Spark Streaming, run complex machine learning with MLlib. It even does graph processing with GraphX. This versatility is huge because it means companies can use one single powerful tool for a ton of different jobs. And its adoption is just massive. We're talking from analyzing e-commerce data at places like Amazon to processing deep space imagery at NASA. Spark really is the engine running behind the scenes of our whole data-driven world.
So what's the big idea here? Well, Spark didn't just make an old process faster. It fundamentally changed the whole approach. It did that by moving the work from slow disk to lightning-fast memory, and by cleverly planning out the entire job before executing even a single step. It really proves that to solve these truly massive problems, sometimes you need a lot more than just speed. You need a smarter strategy.